Okay, we're going to look at section 2.5 today. We're going to be talking about proofs. So the first thing we're going to talk about is just what a proof is. We can use deductive reasoning, which we've been talking about, to show that a conjecture or a guess or a hypothesis is true. So the set of steps that I take is called a proof, and the statement that I prove true is called a theorem. We've seen postulates before, which are just generally accepted rules, but the theorems can actually be shown to be true. I'm trying to get this off my screen. I don't know if you can see it or not. Okay, so the first theorem that we're going to look at is the vertical angles theorem. Remember, vertical angles are the ones that are across from each other, like 1 and 2 in this picture, and 3 and 4. So the vertical angles theorem tells us that vertical angles are congruent. So in that case, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Now, when we start to do a proof, here is what you're going to see. The things that you know are going to be written under a given statement, and what you must show will be written under a prove statement. So they're telling you what you need to prove, and they're telling you what is given, what you can take as true. And then often there'll be a diagram also to show what the given statement is telling you that you know. And sometimes the diagram will show things that aren't listed in the given statement. But you can assume in the diagram whatever is shown is something that you can use as true. So there are many forms of proofs. The first one we're going to look at is a paragraph proof. It's basically written in sentences within a paragraph. So it's just writing out the reason that you can make an assumption and what you're assuming, and doing each sentence is kind of progressing until you get from what you're given to what you're trying to prove. So we're going to prove the vertical angles theorem. What I'm given is in this diagram, this is part of what I'm given, but I'm given that angle 1 and angle 2 are vertical angles. Those are the ones in red. And then I'm asked to prove that angle 1 is congruent to angle 2. So angle 3 is included in my diagram, even though nothing was said about it, but I am going to use it in my proof. So in my paragraph proof, I'm going to start with taking something that I know. When I'm proving the vertical angles theorem, I can't use it. So I can't just automatically say angle 1 is congruent to angle 2 because they're vertical angles. I have to actually show from other reasoning why the angle 1 is congruent to angle 2. So if I use the angle addition postulate, I can say that the measure of angle 1 is plus the measure of angle 3 is equal to 180. Remember, we talked about linear pairs. And so these two, angle 1 and angle 3, make a line when they're put together, which means that they add up to 180 degrees. I can also say that measure of angle 2 is plus measure of angle 3 is equal to 180 as well, because those two angles are also a linear pair. So both of those are by the angle addition postulate, and I listed those. Now, I have measure of angle 1 equals plus measure of angle 3 equals 180, and measure of angle 2 plus measure of angle 3 equals 180. So by substitution, I can say, since they're both equal to 180, that measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. Okay, remember we did say when we were looking at the different properties that you could have also said by the transitive property, since they're both equal to 180. But we just use substitution here. So now if I look at measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3, I see that I have measure of angle 3 on both sides. So I can subtract measure of angle 3 from both sides, and then that leaves me with measure of angle 1 equals measure of angle 2, or angle 1 is congruent to angle 2, which is what I was trying to prove. So we just take what we know and things that we've learned in the first chapter and up to now in chapter 2, those things I can use as I'm trying to get to the prove statement. I really want to get rid of that, but I can't do it. Okay, now example 1 is just going to show us how we can use the vertical angles theorem. So I'm given this diagram where I have two vertical angles and they're labeled 4x and 3x plus 5, and they ask me to find x. So the vertical angles theorem tells me that these two angles that are labeled, if they're vertical angles, they're congruent, or their measures are equal. So I can say 4x equals 3x plus 5. Then I would just subtract 3x from both sides. And I would be left with x equals 5. Okay, so far that's all they've asked me to do. But in Quick Check 1, they ask us to go back and find the measures of the pair of vertical angles that are labeled. So pause this and use x equals 5 and figure out what each of those vertical angles is. Okay, so for the first one, if I plug in 5 into 4x, I get 20. Now clearly my drawing is not to scale. Alright, now if I've done everything right, when I plug this into 3x plus 5, I should get the same answer because they're supposed to be congruent. So 3x plus 5 equals 3 times 5 plus 5, which is 15 plus 5, and that is also 20. Okay, the second part of Quick Check 1 asks you to find the measures of the other pair of vertical angles. So let's just label them 1 and 2. So now pause this and see if you can figure out the measure of angle 1 and angle 2. Okay, so for angle 1, if I were to add that angle to one of the other two angles that it's a linear pair with, it's supplementary. So I'm going to add it to 4x. The angle that's labeled 4x. So the measure of angle 1 plus that 4x should equal 180 degrees. Okay, and we said that 4x was 20, so the measure of angle 1 plus 20 equals 180. Now I can subtract 20 from both sides and I get the measure of angle 1 equals 160. Okay. Since angle 2 is also a linear pair with 4x, I could go through the same steps to find the measure of angle 2, or I could just use the vertical angles theorem to say that the measure of angle 1 is equal to the measure of angle 2, which has to be 160 degrees. So it's okay to use the vertical angles theorem except when we were trying to prove it. That was the only time we couldn't use it. So in this case, we were able to use it, and it makes things a lot quicker for us. Okay, another theorem that we're going to see in this section, Theorem 2.2, is called the congruent supplements theorem. Every book will maybe teach theorems in a different order, so it's hard to just remember the numbers of the theorem. It's easier when they give us a name like congruent supplements theorem or vertical angles theorem. When we use it before, we can easily tell where it came from, what our reasoning is. So it says if two angles are supplements of the same angle, or if congruent angles, then the two angles are congruent. Now remember what supplement means. Supplements mean that when I add the two angles together, I should get 180. So this is telling me that if two angles are each a supplement of the same angle, or if they're supplements of congruent angles, then I can say those two angles are congruent also. So let's look at the proof of this. Here I'm given angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. Those are the angles that they're referencing are in this diagram that I'm given. And then I'm trying to prove that angle 1 is congruent to angle 3. So I start out using the definition of supplementary because that came from my given statement. So by the definition of supplementary angles, if angle 1 and angle 2 are supplementary, that means the measure of angle 1 plus the measure of angle 2 equals 180. And also, since they told me that angle 3 and angle 2 are supplementary, I can say the measure of angle 2, or measure of angle 3, let's start with that, plus the measure of angle 2 equals 180. Now this is similar to the vertical angles theorem proof. Now that I have these two statements, and they're each equal to 180, I can use substitution and say that measure of angle 1 plus measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 2. And then I could subtract from both sides the thing that they have in common, which is the measure of angle 2. Now I will get, if I take away the measure of angle 2, I'll get the measure of angle 1 equals the measure of angle 3. Or that's the same thing as saying angle 1 is congruent to angle 3. So remember, we said the equal sign is used when you're talking about measures or lengths. The congruent sign is used when you're talking about a figure itself or the angles themselves. Okay, so this was very similar to the proof of the vertical angles theorem, and that's because the vertical angles theorem is kind of a special case of the congruent supplements theorem. So it's a smaller case. Not all angles will be vertical angles like these pictured are not vertical angles, but it's almost the same proof as what we just did. Okay, so the last part of this section, we're just going to see three more theorems. Theorem 2.3 is called the congruent complements theorem. So here, if it says if two angles are complements of the same angle or congruent angles, then the two angles are congruent. This is almost the same as the congruent supplements theorem, except this time we're talking about complements. So you have to remember that the complements mean that their measures add up to be 90 degrees, not 180. So supplements add up to 180, complements add up to 90 degrees. So this one is is almost like the others, just complements instead of supplements. Theorem 2.4 doesn't have a name, but it says all right angles are congruent. And Theorem 2.5 says if two angles are congruent and supplementary, then each is a right angle. That makes sense because if the measures have to be equal and they have to add up to 180, then the only thing it could be is a right angle, each of them. Okay, so that's the end of this section. On Thursday, you're going to have a quiz. So you need to know your vocabulary. You need to know the law of syllogism, the law of detachment. I have a few questions there about those, some of the vocabulary and some of the laws, and they're going to be fill in the blank. So you need to know which is which. Like, I guess some of the vocabulary would be hypothesis, conclusion, conditional, converse, biconditional, some of those kind of words. So make sure you look over your vocabulary. And then also, you're going to need to know the names of the properties of equality and congruence. I'm going to have some questions on there that are matching, so I'll show what that property says, and then you'll have the names in a column that you'll have to put the letter for the right property of equality that goes with that illustration of what it is. All right, so let me know if you have any questions, and I'll see you Thursday.